Hey guys, hi. This is Nizam, and you're watching ICSE in one shot. How are you all? All fine? Sorted? So I welcome back all of you to yet another wonderful session, which you're gonna enjoy till the end of the session. So let's start. Today's topic is really a very interesting one. It's electrolysis, a very crucial chapter for the boards in chemistry. So without any further delay, I think it's time to begin our session. So there you go. Okay. See, my voice you would be able to hear. So now, without any further delay, let's begin with the session. Okay. Yes. So it's ICSE in one shot chemistry, all about electrolysis. Yes. So beginning with the session, the most important for me, I suppose, is beginning with a fresh motivational quote. No one can stop you unless you willingly stop yourself. Quoted by Dave Thomas. Believe in yourself and you will succeed. That's the point which I wanted to share with you. So if anyone is new to the channel, please to subscribe the channel and hit like this session and subscribe for the new viewers, all those of you who want to get the further updates. All right. Yes. So let's proceed. Yes. Today's topic is very interesting one. It's all about electrolysis, right? So we need to understand the learning objective, which is first electrolysis itself. So what is actually electrolysis? Electrolysis is composed of two words, namely the electro, which is the means the electricity, and lysis means separation. You see, electro means flow of electrons or electricity, and lysis means separation. Okay, therefore, bringing about a chemical change in a substance by passing the electric current or electricity. As simple as that. Let's proceed. Yes. So we need to understand what is conductors and non-conductors of electricity. Okay. So basically speaking, conductors are the substances which allow the flow of electricity. And examples are, you say, metals that conducts due to the flow of electrons. As well as that, it's the non-conductors which are do not allow the flow of electric current, namely the non-metals such as the as they have no free electrons, so as to suppose. Okay, yes, let's proceed. Now, the important terminology of this chapter you need to understand in depth, which is electrolysis, electrolyte, non-electrolyte, electrolytic cell, electrochemical cell, and electrodes. So let's understand them one by one. Yes. Electrolysis is the process of decomposition of a chemical compound in a aqueous solution or in a molten state accompanied by a chemical change by using direct electric current. As simple as that. Electrolysis is just the simple process of breaking down a chemical substance in the aqueous or molten state accompanied by a chemical change. And this is incomplete without the flow of electricity. Now, electrolyte. Electrolyte is a compound which either an aqueous solution or in the molten state allows the electric current to pass through them. Thus, it actually undergoes the decomposition. As stated, are decomposed by the passage of electricity, namely NaCl, HCl, H2SO4. This is the cell, this is the apparatus or the electrochemical cell, and over here the electrolyte is there that is getting splitted into the two ends of the, namely cathode and anode. Okay, now what is the difference between the metallic conductors and electrolytic conductors? Metallic conductors are the conductors that flow consists of only single stream of electrons from the negative pole towards the positive pole. Whereas electrolytic conductors, that is flow consists of two streams. One is positively cathode and the other one is that of negative anions, cations and anions. In case of metallic conductors, it is both in solid and liquid state are good conductors of electricity, whereas electrolytes are good conductors only in the aqueous or in the molten state. And final difference is no change of form or in the composition occurs during the conduction of electricity. This is also a physical process. Okay, so that is very basics of this very chapter. Next which you're gonna proceed is new products are formed over here at electrodes that involve a chemical change. So that is very basics. Okay, now next, which compounds are electrodes? Yes. Now, which conductors are the electrolytes? See, ionic compounds in which the positive and negative ions are held together by the strong electrostatic force of attraction. See, this NaCl is a compound which is bound by Na plus and Cl minus ions that are oppositely charged, and therefore a very strong force of inter-electronic attraction acts between them. Thus, it is ionic in nature. Next, okay, which compounds are the electrolytes? Actually, polar covalent compounds, namely HCl. HCl, we know the heavy electronegativity of Cl makes it more fractional charge separation is there between H plus and Cl minus in the compound HCl. Therefore, you should take note of this portion. Electrons are shifted more towards the chlorine because of the higher electronegativity. Therefore, they act as efficient electrolytes. Now, examples of electrolytes. Acids are H2SO4, HNO3, H3PO4, HCl. Bases they are NaOH, KOH, NH4OH, calcium hydroxide, etc. And in case of salts, it's NaCl, CuSO4, PbBr2, etc. etc. Next. Now, what are the type of electrolytes? Electrolytes are basically two types. They are strong electrolytes and weak electrolytes. Now, these strong electrolytes, they completely, they are completely broken down in the electrolytic solution in their aqueous state or in the molten state to give heavy amount of charges and free mobile ions. Whereas in case of weak electrolytes, there is a partial breakdown. Therefore, few amount of free mobile ions are released in the aqueous or molten state. Okay. Next. Yeah. Now the types of electrolytes, as I said, strong electrolytes, they're completely dissociated and fused or in the aqueous state. Remember, instead of writing fuse, you can also write molten. That is a substitute. Okay. The second point is these solutions contain almost only free mobile ions. As I stated, they are very good conductors of electricity because of free mobile ions, as well as that it's that they allow a large amount of electricity to flow through them. Justified because they have abundant, ample amount of free mobile ions. And so that is it. Next, it's the type of electrolytes. The examples basically, you need to remember this. HCl, H2SO4, HNO3 for acids. For bases, it is NaOH, KOH respectively, and for salts, it's NaCl, PbBr2, CuCl2, CuSO4, etc. etc. Now, the weak electrolytes. Weak electrolytes, as I said, they are partially dissociated in the fused or the aqueous state. These solutions contain ions as well as molecules. Both they possess ions as well as molecules. Both. They're the poor conductors of electricity. Since they have ions, few amount of ions and molecules respectively, and sideways they allow small amount of electric current to flow through them. Understood? Very nice. Let's proceed. Okay, now the types of electrolytes among the weak ones. Weak ones here is it's acids, which is carbonic acid, that is H2CO3, acetic acid, CH3COOH, oxalic acid, COOH holds twice, and for bases it's calcium hydroxide, ammonium hydroxide, and among salts it's sodium carbonate, sodium bicarbonate, or you can say sodium acetate. That is also a good prominent example. Okay, yes. Now let's proceed. Yeah. Non-electrolytes. They're the compounds which either in the solution or in the molten state do not allow electric current to pass through them. They do not decompose at the electrodes. They practically do not decompose. See, this is for strong and weak electrolyte respectively, and this is for non-electrolyte. Yes, very nice. Now, non-electrolytes do not have ions in their even in their solution. They are only filled up of abundant amount of molecules. Okay. Now, what are the examples of non-electrolytes? It's distilled water, kerosene, carbon disulfide, benzene, glucose, urea, sugar, etc. etc. Now, electrolytic cell, this you need to understand it. Electrolytic cell, it's practically the vessel in which the electrolysis is carried out, which is called the electrolytic cell. The vessel in which electrolysis is carried out is the electrolytic cell or the voltmeter. It converts the electrical energy into chemical energy. Very nice. It is exhibited by simple voltaic cell, or you can say Daniel cell. Okay. Now, electrodes. Now, electrodes are the two metallic plates or wires, or basically the graphite rods, which through which the electric current enters and leaves the electrolyte. These are called the electrodes. Okay. Now, see this anode and cathode. They are respectively the electrodes. Okay. Very nice. Now, the electrodes are being specified over here prominently, which is anode, which means the electrode which is connected to the positive pole of the battery. Positive pole of the battery is called the anode. Similarly, the electrode which is connected to the negative pole of the battery is called the cathode. Okay, now when electric current is turned on, cathode becomes the negatively charged electrode and anode becomes positively charged electrode. Now, a confusion might arise in your mind that which one is positive, which one is negative. Always remember NCR and PAO. NCR, that is negative cathode reduction, and PAO, it means positive anode oxidation. Like this is a very good method which I must myself personally pursue in understanding these concepts. Okay, very nice. Making acronyms is very necessary, okay, for studying with tactics. All right, now, yes, oxidation and reduction. Oxidation is the process of removal of electron, like zinc becomes zinc ion, sodium becomes sodium ion, and yeah, sulfide ion becomes sulfur, so and so. Those are the examples. Similarly, reduction is the process in which atoms or the ions gain electron. Like copper ion gains electron to deposit copper. Similarly, sulfur becomes once again the sulfide ion. The ferric ion becomes ferrous by the addition of one electron. Like this. Okay. Next, it's reduction and oxidation. In a chemical process, it's not that only reduction or oxidation takes place. Practically, in electrolysis, it's redox reaction. Okay, so here you see copper 2 plus is gaining 2 electrons to become copper. So what we knew, gaining means reduction by the gain of electrons, and Mg loses 2 electrons to become Mg2 plus ion. That is the oxidation. Very nice. Next, yeah, what are the reducing and oxidizing agents? Reducing agents means they lose the electrons. Always think of reducing agents as the metals. Metals always they lose electrons. That is, the metal is being oxidized by a non-metal. Here Y is non-metal. That is becomes more positive. Understandable? Very nice. Oxidizing agent, on the other hand, it's Y gains electrons. That is, Y is reduced by X. So, like that way, you have to just brush up with the concepts. Okay, which is very necessary. Okay, very nice. Okay, yeah. So let's continue with the session. Okay, so Y, which is the oxidizing agent that gains electrons. Remember, non-metal always gains electrons, and therefore it is being reduced, and thus it becomes more negative. Okay, very nice. See, if you're having any doubt, you can launch it in the uh, live chat, which I'm reading presently. Or those of you who are watching this as a replay session, you can always comment me down in the comment box. Okay, very nice. So now, what is the theory of electrolytic dissociation? Remember, this is Arrhenius theory. Okay, what happens is that electrolyte on dissolving in water dissociates into free mobile ions, positive and negative, and thus they allow the current to flow. Okay, this is first theory. Secondly, ions carry electric charge. Very clear. Ions are the ones that carry the electric charge. Okay, they're responsible for current flow. Very nice. The conductivity of electrolyte depends upon the ion concentration. This is very important. The conductivity of electrolyte, how much it can conduct the electricity, it all depends upon the ion concentration. Next, its fourth point, which states that charge are equal in solution, hence electrolyte shows equilibrium in ionized molecules as well as ions. Next, point number 5, it's non-electrolytes. They show no ionization as because they have got only molecules, no ions. The degree of dissociation extends to which electrolyte dissociates. I hope you all are able to cope up with me. Okay. Now, the conduction in compounds. What are the conduction in compounds? Okay, now as an ionic compound is made up of charged ions, the conductors are okay, very nice. Next, let's move ahead. It states that as ionic compounds is made up of charged ions, they conduct electricity, but only if the ions can move. Okay? If in the molten state, that is, the ions may move. And if it is in the dissolved state, ions can still move. Okay? So you can either melt the electrolyte or you can dissolve it in the aqueous solution. These are the two ways how you can break down the electrolyte. Thus shows the conduction. Okay. Now, see, point wise, you need to understand electrovalent compounds are the non conductors in the solid state. Solid state, have you seen solid NaCl, which is used to as an electrolyte? No. In solid states, it's bound by strong force of attraction. It is not possible to break that electrolyte at all. Then, what to do? In case of molten or aqueous state, ions may move and conduct electricity. In this case, you can do it. It becomes very easy in this case. Okay. And for case of polar covalent compounds, that is, they ionize in the solution, they conduct the electricity. This is because they have got a frictional charge in them, and whenever they are supplied with electric current, there is the ionization which takes place, and thus the charges become the free ions. Very nice. Now, characteristics of electrolysis. Electricity forces move cations towards the cathode and anions towards the anode. Electricity, it means that ions are broken and they go towards the respective cathode and anode respectively. Number of electrons gained at anode is equals to number of electrons lost at anode. So that is one more point. Products of electrolysis are obtained at electrodes as the reaction occurs at the surface of electrodes. This is a surface phenomenon, basically. Okay. Characteristics of electrolysis. Now, only H2 and metals at a cathode, hence they are called electropositive. Metals are positive in nature, hence they are electropositive, and only non-metals, they gain electrons, therefore they become electronegative. Simple. Now, what is the Faraday's law of electrolysis? It states that the mass of the substance produced directly proportional to the quantity of electric current which is passed through the substance. Okay, that is, the mass of whatever product would be obtained at the cathode and anode respectively is directly proportional to the amount of electric current that the vessel is being supplied to. Okay. Now, characteristics of electrolysis. In electrolysis, it is a redox reaction, that is, at cathode, reduction of cations, and at anode, oxidation of anions. Example is dissociation of sodium chloride. In case of cathode, you can see sodium plus electron becomes sodium, and chlorine, two chlorine ions gain leave or give out two electrons to become chlorine gas. That is the way the thing happens over here. Okay. What are the characteristics of electrolysis? Alternating current, AC current do not cause electrolysis, because in case of AC current, the poles would obviously shift from this end to that end. So it becomes a very scrupulous process. Next, Electrolysis is only caused by direct current, which is very important. Okay. Yes. Next. Yes. So electrolysis dissociation of sodium chloride. In solid state, they do not conduct due to the absence of free ions. Very simple. As I said, now in case of aqueous solution, solvation, free ions conduct electricity. Very clear. In case of molten state, bonds weaken between the ions and therefore they are set free to move. Okay. So bonds weaken between the ions in case of molten compound. Therefore, they are free to move. Very nice. Now, uh, the preferential discharge of ions as electrodes. So, what happens over here is that whenever two or more ions of the similar charges are present in the solution of the electrolyte under the identical conditions, competition exists between who should be discharged at the cathode and anode respectively. Only one of them gets preferentially discharged. Likewise, in a sprinting event, you have seen that not everyone gets the dignity of the first one stumbles down. Similarly, only the uh, what to say ion which is the most below in the electrochemical series that gets preferentially discharged first. Very nice. Now, is this selective discharge of ion depends on what factors? It depends upon the factor of relative position of ions in the electrochemical series, relative concentration of ions, the nature of electrodes. So understand this very clearly, okay, because this is very elementary in understanding the further concepts. All right, so relative position of ions in the electrochemical series, the relative concentration of ions, likewise, and the nature of electrons. Now, the relative position of ions in the electrochemical series. If all other factors are constant, any ion lower in the electrochemical series gets discharged at the relevant electrode in the preference to the above it. See here, in dilute CuSO4 as well as water, because it's in dilute aqueous solution it is. Cu2 plus SO4 2 minus H plus OH minus. So since H plus is below copper, obviously no, it's copper which is below H plus, therefore it gets discharged. Likewise, OH minus is below SO4 2 minus, thus it gets preferentially discharged at cathode, and copper at uh, cathode and OH minus at anode end. Yes. Now, you need to understand about the electrochemical series. In the electrochemical series, it's all these elements you need to understand it. And similarly, fluorine, it's this is over here. So ease of discharge increases. More you go down, it becomes more easy to discharge. Yes, very nice. Guys, are you able to understand the concepts? If yes, then please comment me down either in the live chat or in the comment box. Okay, now concentration of ions in the electrolyte. See, if in an electrolyte has got much concentration of a particular ion, that ion will get discharged at the relative electrode. That is very necessary and elementary. Okay. In the preference to those ions which are lower in the electrochemical series but are present along with them. Very nice. Now, you see here concentration of NaCl solution, concentrated NaCl solution. At cathode, it happens that both Na plus and H3O plus hydronium ion, they migrate towards the cathode, but sodium is much higher than that of hydronium, that is H plus it is considered. Okay. Now sodium discharges in preference with H3O plus irrespective of the higher position to that of the H3O plus in the electrochemical series. So supposedly this was about to be discharged, no, but since it is very concentrated NaCl, so Na plus concentration is more than this, as a result of which sodium gets the preference. Clear? Now, concentration of ions in the electrolyte. In the electrolysis of concentrated NaCl solution, the NaCl is broken down into Na plus and Cl minus ions. Similarly, water gets divided into the hydronium and hydroxyl ions respectively. At anode, chlorine and hydronium ion both migrate at anode, but the concentration of Cl is much higher, as in than that of OH minus. So Cl gets discharged similarly, likewise. Okay. Now, nature of electrodes used. This is very important. Inert electrode, and one more thing would be active electrode. So let's understand that. Inert electrode is something which is electrodes which will not take part in the electrolytic reaction. Electrodes like graphite and platinum. Okay. They will not react with the electrolyte. On the contrary, we have the active electrodes, which is they will take part in the electrolytic reaction like copper, nickel, silver, etc. etc. Now, examples of electrolysis. Electrolysis of molten lead bromide, electrolysis of acidified water using PT electrodes, that is platinum electrodes, then electrolysis of copper sulfate using platinum anode and copper or platinum cathode, then our electrolysis of aqueous copper sulfate using copper electrodes. All these are very necessary and elementary in understanding, and these are the questions that gonna come in your board exam, so understand and prepare them very nicely from the book. I'm giving you an overview. First one is electrolysis of molten lead bromide, which is PBBR2. Okay, the temperature is kept above 300 and the melting point is maintained by continuous heating of the burner. Observations are really very important over here. Okay, make it a point to note down in a notebook, and so that you are able to understand everything in just a nutshell. Okay, now what is this electrolysis of molten lead bromide? The electrolytic cell which is used is crucible made up of silica, and cathode and anode, they are made up of graphite, as they are inert and they are connected by copper wire to the ends of the battery. Okay. Now current is kept 3 amperes and 12 volt, and thus ions are produced Pb2 plus and Br minus. Thus Br minus gets reaches the anode and becomes Br bromine gas, and similarly lead ions, they deposit in the cathode end to give me lead deposit. Observation is brown gas, reddish brown gas is evolved at anode, which is that of bromine, and In case of the cathode, here it's silvery gray lead metal is deposited. Remember these equations, very important. Now, electrolysis of acidified water using platinum electrodes. Distilled water is acidified by small quantity of sulfuric acid. For sulfuric acid that enhances the conductivity of the electrolyte, therefore it acts as an efficient catalyst. Thus, we can call it this reaction as a catalysis reaction. Remember the term, okay? And HCl and HNO3 cannot be used since they're volatile. If you are given in the exam, state a non-volatile gas, without thinking anything, you will just close your eyes and write in the sheet H2SO4. Yes. Okay. Now, electrolysis of acidified water using platinum electrodes. Electrodes here are used, which is platinum foils, which are inert in nature, and they are connected by copper wires to the terminals of the battery, and current is kept 12-volt from a battery. Reactions which happens at cathode and anode respectively are that at cathode you see H plus ions being that migrate towards the cathode. They gain 2 electrons to become 2H, which finally respectively combine to form the molecule which comes out as hydrogen gas. Yes, guys, if I'm getting uh, 10 likes until the end of this session, and those of you who are watching this as a replay, if you are generating 10 likes, okay, I would and you have to comment me, okay, in the comment box, that whether you want the PDF of this session or not. If you want, I may give you, but you need to comment me and reach the like target of 10 likes. Okay. Now at anode portion, what happens is that SO2 minus and OH minus both migrate. As I said, you preferentially discharge of OH minus because OH minus is below in the electrochemical series. 4OH minus becomes 4OH plus 4 electron. Similarly, this 4OH becomes 2H2O and O2. Okay. Therefore, there is a liberation of oxygen gas at anode and the liberation of hydrogen gas at cathode. Okay. Yes. This happens in Hoffman's voltameter. Okay. So this was the thing which was given, that discharge of OH minus disturbs the ionic equilibrium so as to maintain it. More of water ionizes. This comes as a give reason question. So prepare that nicely. Excess of H plus and SO2 minus ions present, are present that increased the concentration of sulfuric acid. Net result is that volumetric ratio of hydrogen is to oxygen gas is 2:1. Okay. So that is it. One more question comes is why there is an increase in the acidity at the anode. At the anode, acidity is increased because of the SO2 minus and H plus ions. They are abundant. Okay. Yes. Very nice. Now the ratio, as I said, you 2:1 volumetric ratio. Read that carefully. Electrolysis of copper sulfate solution using platinum anode on the copper or platinum cathode. Now, electrolyte, which is the saturated solution of copper sulfate, is prepared in a distilled water with a small amount of concentrated sulfuric acid. As I said you, next portion is the electrolysis of copper sulfate using platinum anode and platinum or copper cathode. Yes, So this is the apparatus as you are assuming it: platinum cathode, platinum anode, and you can replace this cathode with a platinum, or I mean copper. Okay. Now, electrolysis of copper sulfate using platinum anode and copper or platinum cathode. What happens is that you see the similar reaction. I'm not going in depth that much. Ions present: copper, Cu2 plus, H plus, SO42 minus, and OH minus respectively. What happens is that electrolysis of copper sulfate, yes, reaction at cathode, copper ions are below H plus ions in the activity series. Okay, therefore CO2 plus is getting discharge preference as compared to H plus. Therefore, copper atoms they deposit at the cathode. Very nice. Now, what happens at anode? You say SO42 minus and OH minus both get accumulated at the anode, but what happens? OH minus is below SO42 minus, therefore they are getting discharged. Similar reactions as we learned in the case of electrolysis of distilled water is the same. Now, products of at anode, which is oxygen gas, and reddish brown deposit of copper at cathode. When the deposition is completed, electrolysis of water takes place. See, whenever this deposition is complete, then after that your water is decomposed. In that case, the hydrogen gas is being liberated at cathode and oxygen gas is being liberated at anode. Okay. Now, electrolysis of aqueous copper sulfate by using copper electrodes. Now, aqueous copper sulfate is being taken as electrolyte, and electrodes is both copper as anode and cathode respectively. Ordinary temperature and voltage 12 volt, and current is 3 amperes. What happens now is that in the electrolysis of aqueous copper sulfate using this copper electrodes, the dissociation of copper sulfate brings me Cu2 plus and SO42 minus ions. Similarly, water is being broken down to give me H plus and OH minus. Thus, the ions present is Cu2 plus and H plus, SO42 minus, and OH minus respectively. Here what happens is that there is a nature of anode, which is, since the it is an active electrode copper, and in the anode no more OH would be decomposed and oxygen would be liberated. Now the thing which would happen is that Cu2 plus would itself get broken down to give copper ions at anode, and copper ions would itself gain electron and deposit at cathode. This is a very important concept of electroplating. Okay. Now, what happens over here now is that electrolysis of your aqueous copper sulfate using copper electrodes. Okay, so now products at anode nil. No, nothing is formed at anode as of such, because copper anode keeps on dissolving in the reaction. We knew that copper anode is itself getting decomposed, so what would deposit at anode? Nothing. The deposition would be at cathode, which is the reddish brown deposit of copper. Here the copper ion concentration is being maintained, therefore there the copper sulfate blue color is being retained at the end of the reaction. Okay, important observation. Now electrolysis, the same thing, which is iron crucible or the glass voltmeter, and this is the thing, simple yet too basic and fundamental in understanding. Anode keeps on, C positive is anode, keeps on dissolving copper ions, and copper ions is being deposited at cathode. Simple. Now, application of electrolysis is electrolysis with electroplating with metals, electrorefining, and extraction. Let's understand them one by one. Now comes the interesting part. Electroplating is the process by which a thin film of metals like the gold, silver, nickel, chromium, etc. gets deposited on another metallic article with the help of electricity. Now, without going much in depth presently, the thing which I wanted to tell all of you is that, okay, so here I am. uh, I wanted to show you something very important. Okay, that is, yes, our beloved channel. Okay, so this is ICSE in one shot. We've got 20 subscribers. Thank you all of you for your help and cooperation. This is the live session which is going on, and we've got many videos. This is the ARG exam pressure, which is the latest video which I have put up in the channel. I hope so. You all have gone through that video. The response is very good from your all of your side. Thank you very much. And I've already made the playlist over here. Okay, that is info hub, VIP series, geography, history, motivational hub, chemistry mentor quiz sessions, biology mentor quiz sessions, ICSE Selena physics mentor quiz. Everything is ready at your hands. You have to just subscribe the channel, like the sessions, and support me likewise. Okay, so that was the thing which I wanted to tell to you, all of you. So let's get back to the session which we were continuing. Okay. Yes. Very nice. Okay. all those who have managed till the end of this session is that electrolysis. Okay, now session. I know I had been on a mute, so extremely sorry. You have to work with the PDF, and I'll be surely putting up the PDF once we reach the like aim as I provided to you, the 10 likes. And uh, if I'm getting, I need to get the comments of most of you. Okay, unless I get the comment of all of you whether you want this session or not, that is the very crucial point. Okay, so with this we end up with the session. This is Nizam signing off for the session. Thank you for watching. Stay healthy, take care of yourself, and thus we end the session. Thank you once again. Peace.